All right, good morning or afternoon. Sorry for the late video post, but we are going to continue with our types of free response questions, do a couple practice problems, same as before. And yeah, I'm going to try to keep this short and sweet, so let you read over a lot of it and try some of these on your own. But again, I'm just going to do two free responses. And these days, I only got 5 days of this. We're in day two. We did day one yesterday. And whenever we've whenever we've done these in the past or last year, it was when we had a full AP exam. So I had the types broken down, which ones are being tested most often, just based off of pattern. And in this day, I'm going to keep it in the same order for future use, especially. I have particle in motion. Okay, that's a common question, and also parametric motion. Okay, which parametric, it's part of Unit 9. Well, Unit 9 in terms of the AP exam. Okay, and they've completely eliminated Unit 9 from the AP exam. So really we can just do one type today. I'm still going to go through the parametric type just for the sake of knowledge. And you can watch it if you want, but really once we're done with type 2, that's really the most helpful review for the AP exam. Okay, so starting off with a question with, so this is what we're going to do. We're going to do a question with particle in motion. Okay, talk about some common questions, go over it, things in a summary of it, just like yesterday. Then we're going to do parametric. And again, once we reach parametric, this is like slide 6. You don't have to keep listening, but it's good review. And we'll go over that as well. All right, so we should be pretty good. All right, so start back at the very beginning here. So let's do what I consider the warm-up. So we're going to go over our just a quick question with it. Okay. So again, as I'm doing this, I'm filling out like notes. So on here, so like I'm trying to save a lot of space. So especially because I only have so much space. So not everything that I write is exactly what I would write on the final exam. So to keep that in mind, just kind of listen to more of what I'm saying, and just you can write down some quick notes. But we'll start with A. Okay. So it says a particle moves along the x-axis so that its velocity v at time t between 0 and 5 seconds is given by this function for velocity, this natural log. All right, it's natural log right here. The particle is at position x equals 8 at time equals 0. So when time is equal to 0, my initial position that I'm at is equal to 8. It's going to be helpful for later on. Okay. Biggest thing to keep in mind here with particle in motion is to remember this relationship. S of t is the position, moves to v of t by taking the derivative, and then we go v of t to a of t by again taking the derivative. So that's a big relationship we need to remember. Okay. Part A says find the acceleration of the particle at time equals 4. Okay. And in 2005, question 3 was active. So I'll let you keep that in mind. But it says find the acceleration of the particle at time equals 4. Well, we got the velocity, and the relationship between a velocity and acceleration is that I take the derivative. So all it wants me to do is take the derivative of this, okay, and plug in t equals 4 into it. Now we can do this in the calculators, calcactive, and hopefully you remember how to do it in the calculator. If not, you can ask me later and we can show it, but just to again show it by hand for future references. Okay, so a of t, which is equal to v prime of t, is equal to, all right, the derivative of ln of t squared minus 3t plus 3. So that's going to be 1 over quantity, so t squared minus 3t plus 3. Okay, that's an equal symbol. So then times the derivative of the inside of ln, so that's going to be 2t minus 3. Okay, and then all we have to do from there is figure out what v prime of 4 is. So I'm going to plug 4 into all that mess, and I'll let you pause the video if you want, or try it on your own. But when you type that in the calculator, it simplifies down to 5/7. And as far as the units go, does it say what time is. Particle moves along the x-axis. It does not give a unit of measurement here. It doesn't tell us time. It doesn't say seconds or hours. So if it doesn't tell you seconds or hours or anything like that, you do not have to put a unit of measurement. So the acceleration of the particle is 5/7, units per second squared or units per time squared. Okay. All right, let's move on to B. So B says find all times t in the open interval between 0 and 5, which the particle changes directions. Okay, and if you notice, I'm picking questions that, or the questions that were picked, were questions that are practicing like a lot of the basics that you need to know with this. A lot of concepts you need to know. The math may not be the craziest right now, but it's concepts you got to keep in mind with keywords. It says changes direction. We figure out where a particle changes direction when v of t equals 0. So it changes directions when v of t equals 0. So that's what we need to do. We need to take our v of t equation, which we got, set it equal to 0, and solve. So we're going to do that first. So we're going to say, all right, my v of t equation is the ln t squared minus 3t plus 3. Set that equal to 0. And again, this was a calc-active problem, so you could have done this in the calculator, no problem. But just to practice a little bit, I think it's a pretty good problem to solve for 0. Like, remember, this is base e, so I can actually say e to the 0, which is just 1, is equal to t squared minus 3t plus 3. And I can move that e to the 0 or that 1 to the side, and what I'm left with is t squared minus 3t plus 2 equals 0, which factors to t minus 2 and t minus 1, which equals 0. So t equals 2 and 1, both of which are in my interval 0 to 5. Okay. So find all the times when it changes directions. Well, let's make sure that it actually changes directions at those points. Okay. It could very well just stop and then continue moving. It could rest and then not change direction. So we always want to test these points on a number line. Here's 1 and 2. And if you test these, I'm going to test it in the velocity equation. I'll probably test it in this equation right here. Test points to check the sign, see when velocity is positive and negative. If I plug in, and honestly, we're between 0 and 5 as well on my interval. I don't know, test 0.5, you're going to get negative times a negative, which is a positive. Test 1.5, you're going to get a negative. And if you test like 3, it's going to be positive. Okay. So yes, the times at which it changes 0 is at time equals 2 and 1. And the follow-up question is, when does the particle, if at all, does it travel left? Yes, it does. It travels left when we're in the negative direction. So it travels left when we're between 1 and 2. Okay. All right. Good question. Let's try the position function. All right. So find the position of the particle at time equals 2. All right. So position is working backwards from velocity to my position. So if I'm given the velocity and I'm wanting to work backwards, that's going to be the integral. Okay. Now, if I'm talking about a particular point, all right, like a particular point, then I can talk about like where I'm initially starting from and talk about my accumulation of distance from the beginning to where I want to be. So for instance, I know where I'm positioned at time equals 0. Now I'll know where I'm positioned at time equals 2. So I'm going to start off with my position at time equals 0, which is 8. Let me see. So I'm going to say 8. And then plus my change in distance or change in position from time equals 0 to time equals 2. So it's going to be 8 plus the integral 0 to 2, and then of my velocity function, which is ln t squared minus 3t plus 3. Okay. So, yeah, this is calc-active for sure, so I would not recommend trying to do that in the calculator, do the integration of ln of all that mess in the calculator. But when I did it in the calculator, I got 8.369. Okay. So that's just a formula, talking about position from velocity. And again, the last one right here, average speed of the particle over the interval 0 to 2. It's asking for an average value. So we have a formula for average value. That is 1 over b minus a times the integral from a to b, which in this case is 0 to 2, okay, of the function I'm trying to find the average of, which in this case is speed, okay. So that's 1 over 2 minus 0, 1/2, 0 to 2. And the formula for speed is nothing more than the absolute value of v of t. We actually learned that in the parametrics unit and recently, okay. So this is going to be the 1/2, 0 to 2, the absolute value of ln of t squared minus 3t plus 3. And again, this is calc-active, so I would just do that whole thing in the calculator, and when I did it, I got that it equals 0.371. All right, not so bad of a problem, but it's practicing those key ideas that come with my particle in motion problem. Okay, so I've got a couple minutes. I'll go. Oh, there's the answer key. Forgot about the answer key. So we've kind of done all this already. So like we came up with this answer. We did the math for that. So it's just a point for that one. We get a point for setting it equal to 0. That was the idea. That was the rule for B. We get a point for finding 1 and 2. And again, I would test those points, which is essentially what they did right here. But then they gave us an interval for which it's turning left with a reason. And the reason was, again, this part right there. So that's 3 points. For C, we get a point for setting up the correct integral. All right. And another point for making sure to include the initial condition. So that's a point for this 8 right here, and a point for that integral right there, and then a point for the answer. So that's how you work backwards. Sometimes you can actually take the integral of s of t or v of t and solve for c, but you can't really integrate ln of that quantity, so this had to be done in the calculator, so there's only one way to get points here. And then D was just knowing the formula, so that's 1 point, and then getting the answer from the calculator, that's the other point. Okay. All right, here's a little summary of all things dealing with particles on motion. It's a pretty good summary. It talks about a lot of the stuff we just did, but things to kind of keep in mind here. I won't necessarily read through all this with you, or maybe I will. But it says these questions may have the position equation and the velocity equation or the acceleration equation. It could have those 3 equations we talked about, and we just got to know the relationships between each one and know which one's the derivative, which one's the integral, that kind of stuff. The particle could be a person, it could be a car, it could be anything really. There is a lot of different stuff they can ask, but here's kind of a breakdown of what you need to know for the exam, I guess. No total distance. Remember, total distance was the absolute value of v of t. Now, if this calc active, you can just kind of set it up just like that and do it in the calculator. But if it's inactive, remember, you're going to have to figure out like some c value sometimes if it changes positions between a and b. Like if there's a point at which it changes positions, let's say at point c, then you have to split up the interval a to c of the absolute value of v of t dt, and then plus the integral c to b of absolute value of v of t dt. So if you're doing it by hand, again, you got to break it up at that c value where it changes directions. Now, it's not always, but that's the first thing you should check when talking about total distance, unless it's calc active, then just do it in the calculator. The net distance, okay, so this is displacement, and that's the same thing as total distance, but without the absolute value. It's where initially where you start to where you end, what that difference is. The final position, which we just did in part D in that last problem, is taking an initial. I would always set it up this way if I could, instead of actually solving for C. I would always take my initial position plus my change or my accumulation of distance and time, and then add those together. Speed of a particle is just the absolute value of v of t. So we've talked about that. Average speed we just did. Remember, that's 1 over b minus a of something. Everything else is pretty. Oh yeah, when the speed is increasing or decreasing. Remember how that worked? At some time, the velocity and acceleration have the same sign and the speed is increasing, or two different signs and they're slowing down. So remember, like we would have v of t and we would have a of t. If they had the same signs, okay, if that was the case, then the speed is increasing. But if we had opposite signs, then it was decreasing. They were actually acting against each other. So that's a good one to know. Difference quotient to approximate derivative. And Riemann sum approximations, we talked about that yesterday. Make sure you do your units of measurement and be able to know how to interpret the answers you find always. But just remember that the difference quotient is for rate of change. So that's like f of a minus f of b over a minus b. So remember that's used to find slope or estimate rate of change, which is different than average value. So this is average rate of change. Average value is actually 1 over b minus a integral a to b of whatever function you're trying to find the average of. Okay. So just things to keep in mind. And a lot of this really y'all did well with. This a lot of review from AB, but yeah. All right. All right, so that took like 16 minutes. So there's your review of particles and motions, and here again is a lot of questions between the span of 98 to 2006. You see that this pattern's going on a lot. Here's a bunch of problems to try if you really want to. Okay, a bunch of different questions they can ask, a bunch of different things that you're given, so you can test any number of these. Okay. Now, the next half of this was supposed to be parametric in motion, like a parametric equation where they give you like an x equals and a y equals with a parameter t or a derivative given. In this case, this example I'm doing, they're giving you the derivative. So I suggest watching this. I'm going to try another like 15 or 10 or 15 minutes on this. I'm not going to spend too much time, but for those that want that extra review on this stuff just for the heck of it, here you go. It says, so parametric example, parametric. 2006, an object moving along a curve in the xy plane is at position x of t and y of t at time t, so there's your parameter. But it's not giving you those explicitly, it's telling you their rates of change. So it's telling you the rate of change of x and the rate of change is y. And this is for all of time greater than 0. At time equals 1, so look again, they're giving you an initial position. They're saying at time equals 1, initially I'm at the x position of 2 and the y position of negative 3, which is very important. Okay? So let's go down the list of things we might need to know for parametric if they ever do come up. Write an equation of the line tangent. I told you guys a bunch of times that tangent line shows up with any unit we can do. Write an equation for the tangent line at the point 2, negative 3. Well, there you go. They're given x, you're given y. The only thing we need now is dy over dx. dy over dx. That's the only thing we need. And we need dy over dx at this position, which that position initially is at time equals 1. Okay? Well, just remember how derivatives work for parametric. It's just your dy over dt divided by your dx over dt, which both of those are given right here. Okay, so all I got to do is take my dy over dt, which is the secant of e to the negative t, and divide that by my dx over dt, which is my tan of e to the negative t. And this question was calc active, so that's all you needed to know was how to set it up. And if you did this out in the calculator, at least when I did, I got 2.781. Okay. So if it wants to know the tangent line, we just plug those into our tangent line equation. And I'm getting that that's y minus or plus 3 equals 2.781 times x minus 2. All right. So you have it. There's your tangent line equation. Easy enough. Let's do B. B says find the acceleration vector and the speed of the object at time equals 1. Okay. So again, this is calc active. So if I want to find the acceleration vector, all I have to do is do the x equation and the y equation in the calculator under your derivative menu, which I think is pretty easy to do. But just for a little bit of practice, let's find the actual equation for the acceleration vector. Let's take the derivative of each of these because we're given velocity. To find acceleration, we just take derivative. So that's going to be the second derivative. All right. Second derivative. If I take the derivative of tan e to the negative t, it's chain rule. Derivative of tan is secant squared. So that's secant squared of quantity. And then times the derivative of the quantity, which is just e to the negative t. And then times the inside of that, which is negative 1. So we had three or two chains there, I guess. So that was good practice. And if I were to plug, it wanted to know the vector at 1, which we'll plug 1 into that in a second, but let's go ahead and find y double prime first. So y double prime is the derivative of secant e to the negative t, which the derivative of secant is secant tangent of quantity. So secant negative t tangent e to the negative t, and then times the derivative of the inside, which again is e to the negative t times negative 1. So again, that could have been done in the calculator, but there's the values. And if I plug 1 into your x and into your y, the values that I get in vector form, what I got was negative 4.23, or no, I misread my own handwriting. That is negative 0.423, comma, negative 0.152. There you go. There's B. Okay. All right. So total distance traveled by the object over the time 1 to 2. If I want to know total distance, it's still the same exact formula as the last one. If you noticed, it's still going to be the integral of the absolute value of v of t. So that's just a formula that's need to be known in parametrics. That's going to be the integral. Let's know the distance between 1 and 2. So the integral 1 to 2 of the absolute value of v of t. Okay, which in parametric form is the same thing as saying the square root or the magnitude of velocity, right? Because the absolute value of v of t is the magnitude of velocity, which in this case is the square root of x prime of t squared plus y prime of t squared. So again, this is your total distance. Okay. So you want to plug literally tan equation in for x, or I'm sorry, the derivative equation in for x, as well as the derivative equation for, oh, I'm so sorry, we're given those, yes. So you want to plug this equation in for x and this equation in for y, okay? And do the integral of that. Again, calc active, I wouldn't try to do that without a calculator. And when I did it, I got 1.059, and it doesn't give me units of measurement, I don't believe. No, it's just 1.059 units, whatever the value is. Okay. So A, B, and C, there's formulas, just stuff you need to know there. But D is an interesting problem. D is a little weird. It says, is there a time t greater than or equal to 0 at which the object is on the y-axis? Explain why or explain why not. All right, let's draw a picture to think about this. Okay, this is the y-axis. Okay, we know what the y-axis is. I want to know if there's any time, and remember that we're talking about time greater than 0 here. If there's any time greater than or equal to 0 where I'm on that y-axis. Okay. Well, the position at time equals 1 is over 1, 2, down 1, 2, 3. This is initially where I'm starting off at at time equals 1. Okay. Now I need to know if I ever go over here. Okay, I need to know if I ever go over to the left. Well, if I increase my time, if I go time equals 2, time equals 3, time equals 4, time equals 5, time equals 6, the derivative function, those values that I plug in for t, will always be positive. Okay, you can even check your calculator if you want to, which I have it graphed right here if you can see it. I should change my windows to 0 to 10. So if you notice, any value that I plug in t into and I'm plugging this into my derivative function x, okay, if I plug that in, like any t value into that greater than 1, it's always going to be positive, which means the function is always going to be increasing. So time 2, time 3, time 4, it's always going to be moving in the right direction because the derivative is always positive. Now, what about between time equals 0 and time equals 1? What about where I started off at time equals 0? What about going backwards? Okay. So I need to know if I initially at time equals 0 started off somewhere over here or somewhere over here. See if it works. There's an easy way of figuring that out. I can take my position. I can take my position at time equals 1, which in this case is x equals 2. Okay. And I can subtract the accumulated distance from 0 to 1. So initially where I started off at 0 to where I ended up at 1, and see if that ever was back into a negative direction or if that was ever back on 0. Okay. So I'm going to take that of my x equation, which in this case is tan e to the negative t. And if you type that in the calculator, you get 1.224 blah, 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 blah. Meaning, at time equals 0, I was somewhere like right here. All right, time equals 0, I was like right here, and then I moved forward. At no point was I ever across the y-axis. So there's your explanation. The x value has always been greater than 0 for all of time equals greater than 0. We showed that here, and we discussed x prime of t always being greater than or equal to 0, meaning for any time greater than or equal to 1, I'm always moving to the right. So at no point do I cross over that y-axis. Okay. Here, I'll show you how they explained it in the answer key. They give you a point for, their first point was actually the discussion we just ended with. The discussion for x sub 0, like where you're at time equals 0, which in this case we got 1 point something, which is that value, which is greater than 0. So initially they're like, okay, at the start we're still positive, and number 2, the derivative is always increasing. Therefore, if I'm starting positive and I'm always increasing, there is no point at which I'm going to go back and cross over that y-axis. That was worth a whopping 3 points. Okay, that was a hard problem. I'll be honest with you. When I first did it, I only did that part. I only did when the derivative was greater than 0. I failed to think about it going backwards to 0. I just left that out of my mind, so I missed that piece of it. It was a good problem. Equation line was no big deal. Acceleration vector, speed vector. This one was just setting up a formula and getting the answer. So there you have it. Okay. My goal was to keep this under 30 minutes, and I'm at 29 minutes. So just to give you a little bit of a recap here of parametric equations. I mean, there you have it. There's a good summary. It's not the biggest deal that you talk about that right now or read over that because, again, it's not a part of your curriculum for this AP exam. But so I'm not going to go into too much detail, but it does talk about the speed. Okay. It does discuss knowing how to find arc length, okay, and find the distance traveled. All right, so we have formulas for that. Maybe surface area if you really want to. but yeah, so not the biggest deal in the world. Arc length and total distance traveled is the same thing. So it would be the integral of absolute value of v of t dt. Okay. So that's your arc length. Surface area, it doesn't give on here. That's the only other thing. In case you're wondering, surface area is equal to 2 pi, the integration, a to b, whatever it is, of y times my arc length or my speed, which is equal to that right there, dt. But that's more so just to help you in a later course if you need it, and just a good review there. Okay. So I'm officially over 30 minutes, so I'll go ahead and stop. But appreciate you guys. Y'all are awesome. Here's some parametric equations to try if you want to as well. Oh, and so that's throughout the years. Also, too, guys, if you go on here, we're in day 2. Okay. So I've already kind of posted some practice for you. If you go to homework practice here, it has parametrics in there as well. So I mean, you don't have to do those if you don't want to, but I guess I would recommend for you to study is these the first 3. The first 3 is just regular like particles and motions. So I could visualize maybe seeing those coming up. So there you go. Alrighty, that does it, and I hope y'all have a great day. I'll let y'all know whenever live stuff for like live lessons continues, but for now it's just gonna be video lessons. So good job. See y'all.